Hello students, in this lab exercise 4 we're going to look at regression analysis. The instructions and Excel data are found in the course Blackboard. So you should pull up the lab exercise instruction sheet. We're going to look at, in this video, looking at step number 2, looking at the relationship between salary and wins in Major League Baseball. We're going to determine Pearson's correlation coefficient, coefficient of determination, the intercept, slope, putting those two together to get that regression equation, and then answering the question about the significant relationship between salary and wins at the 5% level. Let's take a look at our Excel data. So here is baseball data for the 2019 season. Various wins, and then a whole bunch of other variables. We're going to first look at this other sheet with salary. So this comes from Appendix C. We took a look at this data in the first unit. So the 30 baseball teams 2010 had salaries ranging from anywhere from about 35 million to just over 200 million, and various wins. The purpose of regression analysis is to determine if there is a relationship between two variables. In simple linear regression, we look at one independent variable, which in this case is payroll, and one dependent variable, which in this case is wins. If it's a good predictor of wins, then we should see that teams generally with higher payroll have more wins, as you know, with the assumption that higher payroll, you get better players, and you therefore get more wins. So let's take a look at how we can answer some of those questions in that instruction sheet. First thing you need to do is go to the data, and you should have this data analysis add-in, which I don't have, so which is good. Good reminder of how to do this. So you go into the File menu, go into Options, click on Add-ins, click in Add-ins, come on, and then go and then make sure this first one is checked, and there we have it. Now under the Data tab, we should have Data Analysis. Click on Data Analysis, and in time we will get this pop-up window. We want to move this down until we get to regression. Click OK. In simple linear regression, we have two variables. The input, the y variable, which is our dependent variable wins, and we have one independent variable, which in this case is payroll as our x value. Include the labels. As we've done here, we've included the labels, which makes it easier to read some of the Excel output. And basically, let's send this to the same sheet. So let's just pick a cell here, and there it is. And in time, we will get this. We don't need the last two columns. Those ones there. Let's delete that. Let's extend column width for some of these columns, as well as this one and column H. Now what we have, we can highlight these values in yellow. We have multiple R, which is Pearson correlation coefficient. We have R squared, which is a coefficient of determination. We have the intercept, and we have the slope. And the slope has that scientific notation in it, -0.07. So basically it means there's 0.0 and there's 6 zeros and then a 1. So it's a very small number. The size of the slope, which is a payroll number, does not indicate if there is a significant relationship between the two variables. Basically, it's saying that the slope is almost 0, but the slope is almost zero because of the differences in the variables between payroll and wins. If you look at payroll, these values are anywhere from, as I said, 35 million to 200 million. Wins, basically all within 30 or so, 40 of each other. So it's a very small difference in wins, large difference in payroll is going to amount to some of that difference in payroll in the slope. The other variable we need, which is right here, the p-value for the slope, which is the same in simple linear regression as a significance f value. Now if we look back at our instruction sheet, we wanted to find Pearson coefficient of determination, intercept, slope, putting them together to get that regression equation and answering part F about the significant relationship. The first 5 we can actually find without doing the Excel output or the data analysis. We can find them by using some built-in Excel functions. Pearson equals Pearson bracket array 1. Doesn't matter the order, if it's x then y or y then x, and we get the same value. We get 0.3672. Coefficient of determination is simply r value squared, and so we get a value of 13.4. We generally change that to percent. 13.48%. Basically that means that the unknownness in wins is accounted for, or 13.5% of the variability or the unknownness in wins is accounted for by using payroll. So one variable has accounted for about 13.5% of the variation in wins. Intercept can be found as well by using the built-in Excel function intercept bracket. Now know that there's a difference. We enter the y values first without the labels, and then we enter the x values. And we will get the same intercept, 71.357. Same thing with slope. We can do that. The y's, comma, all of the x's. And we will get that same value. As I said before, a relatively small value. Now the only value that we can't get is the p-value for the slope or the significance f value, which is the significance of the overall relationship. Now because there's only one independent variable, these two values here are going to be the same. Now the question states or asks us to determine if there is a significant relationship between salary or payroll and wins at the 5% level of alpha. The p-value here, as well as the significance f value, is less than 5%. So we are going to reject the null hypotheses because the p-value is less than alpha, and then state that there is a significant relationship between payroll or salary and wins. The other part to this is, other part of this question is, what is the relationship between salary and wins? Well, the slope is positive, so there is a positive relationship, and it's significant. So positive, significant relationship between payroll and wins. As payroll increases, wins increases. Now part E was the regression equation. So let's bring our Excel data up again. The regression equation is simply going to be written as estimated y, and that comes with that fancy y symbol. Let's make this a little bigger. So estimated y is going to equal the slope, the intercept, 71. Where did I go here? 71.36 plus, my keyboards aren't working, plus the slope of 1.06. Actually, let's put that, 1.06 e negative 0.7 times x. So then we can use this estimated regression equation to solve for, or to determine any number of wins, y, given any payroll. So payroll is x, so we would type in maybe 100 million into the equation, and we would be able to determine what the estimated number of wins would be.